All right, so I wanted to make a video going over some of the questions that you guys mentioned from the test cards. Someone brought up the Kahoot challenge, so I thought that would be a great place to start since it was a pretty tricky problem. For the audio on this video, my computer is making a weird rattling sound, so I apologize if it's annoying. Hopefully you're able to still listen. For this problem where you're multiplying three binomials, I think the best strategy is to start just by focusing on the first two. So you can FOIL it out. X times 7x is 7x squared minus x minus 7x plus 1. You would combine like terms like you normally do. 7x squared minus 8x plus 1. And then you're going to take that trinomial and multiply it with the other binomial. So from here, you could distribute everything out. I think once it gets into trinomials, that's when it becomes a really good idea to think about the area model. You know you're multiplying two terms by three terms, so you could easily set up something like this. A lot of times we avoid it because it seems like more work or just kind of more space in our notebooks than we need to use. But once it gets into anything larger than a binomial, I think it's a good organizational strategy. So if you find that you're off a little bit or you're missing terms or missing little exponents here and there, I think the area model is a good idea to pursue. All right, a lot of people mentioned problem 1 and problem 2. So one thing I want to point out, if you look at problem 1, there's no addition or subtraction. It's a monomial times a monomial times a monomial. So that means all we're really going to do is regroup. We're going to say, all right, my coefficients is 2 times negative 3 times 5. My a values, I have a squared times a squared times a. B values, I have b to the 4th times b squared times b. So it's been a while since we did this. This is closer to just our initial work with exponent rules. 2 times negative 3 times 5, we're going to have negative 30. A squared times a squared times a, we have 2 more, 1 more. We're going to have 5 a's if we picture that expansion, a to the 5th, b to the 4th times b squared times b, 4, 2 more makes 6, 1 more makes b to the 7th. So for that one, I would just rearrange, regroup, and then multiply it out, thinking about the expansion. On problem 2, where we do have addition or subtraction, that's where we're distributing. This is another one where there's no addition or subtraction, so you're going to carefully think, all right, I have coefficients. 1/4 times 8 is 2. Then I have r values. R to the 2nd, r to the 3rd, that would give us r to the 5th. S values, I have s, and I find another one with s to the 4th, so we have s to the 5th. I also have a t squared and t to the 6th, 2 and 6 more, we're going to have t to the 8th. Different colors, different shapes, different ways of underlining it can be a good way to kind of differentiate what you're working with if this is something you've been struggling with. The last one I wanted to go over was this word problem. The length of a rectangle is 3 meters shorter than its width. So I hope everyone, once it said rectangle, sketch something out. The length is 3 meters shorter than the width. I don't know what the width is, but I know that this is 3 meters less. So we might say that the length equals, or you could just define it in terms of W. Write a polynomial that represents the area of the rectangle. That would be something like the width times the width minus 3. So if I actually distribute it out, W squared minus 3W. Then for the second problem, find the area of the rectangle when the width is 6 meters. We'd be able to substitute that in. 6 squared minus 3W, and then we'd evaluate.